afternoon, guys. Welcome to another lecture for computer organization 2. Okay, let us start with the question number 3. So here the given thing is convert the following numerical arithmetic expression into the reverse following notation and show the stack operation to evaluate the numerical result. So we have to first convert this given expression in terms of reverse Polish notation, okay, RPN form. So to convert into RPM form, first just we need to write it 2 plus 3. Just we will underline the operation. Okay, 2 plus 3 cross 10 cross 1 plus 3 plus 4 divided by 2. Okay, sorry, this bracket is here. So that means this is inside operation, this is inside operation. So so let us just 2 comma 3 plus, okay, cross 10 cross 1 comma 3 plus 4 over 2. This is here, and the bracket is here. Bracket is not good, the bracket is here. So it will be 2 comma 3 plus cross. So first inside operation is this, and the inside operation is this. Then 10 comma 1 comma 3 plus cross plus 4 divided by 2. So 2 comma 3 plus cross 10 comma 1 comma 3. This plus and cross is already shifted. Okay, this is 4. That means this term is adding with 4. Okay, plus this plus will come here and divide by 2. So then 2 comma 3 plus, and actually when you write this expression it is like this. Okay, 2 plus 3 cross 10 cross 1 plus 3 plus 4 divided by 2. So this is divided by 2. Okay, so that means this term is divided by 2. Okay, so this expression is dividing by 2. Okay, so that means this is the last operation. Okay, so it is 10 comma 1 comma 3 plus cross 4 plus cross by 2 comma 3 plus 10 comma 1 comma 3 plus cross 4 plus cross 2. Okay, so this is what, this is the RPN, reverse Polish notation. Okay, so now we have to convert this, evaluate this RPN in terms of, we have to arrange this in terms of stack and solve the numerical expression. Okay, so let us just arrange in terms of stack. So 2, 3 plus 10, 1, 3 plus cos 4 plus cos 2, right? Okay, 2, 3 plus 10, 1, 3 plus cos 4 plus cos 2 y. Okay, so now, so this is the stack here. So this is 2, this is 2 comma 3, and here it is 2 plus 3, which is equals to 5. Okay, 5 comma 10. Okay, 10 is entering, 5 comma 10 comma 1, 5 comma 10 comma 1 comma 3, 5 comma 10. Okay, this plus will enter from last, that means pop 1. Okay, this will become 4, so it will be 5 comma 10 comma 5 comma 10 comma 4. Okay, this will pop here, push, sorry, push, and 10 cross 4 will be 40, then it becomes 5 comma 40. Okay, 5 comma 10 comma 40 comma 4, so it will be 5 comma 44. That means this plus will pop in, so 44, 5 cross 44 becomes 220, 220 comma 2, this become 220 by 2 become 110. This is the, this is stack. Okay, we got the mathematical expression result to 110. Okay, this way we solve. The memory unit of the computer has 250 kilowatt of 32 bit each. Okay, that means it has 256 kilo, sorry, 256 kilo of kilowatts. Okay, word means 32 bit. Okay, this is by 32, suppose. The computer has the instruction format of 4 fields. You have instruction format with the 4 fields. What are the 4 fields? 1, 2, 3, 4. Okay, an opcode field, operation code, that means opcode. Okay, and mode field to specify an operation code field, that means it is unknown here. And the mode field to specify one of the 7 addressing mode. Okay, so mode is given as 7 addressing modes, and it is given. Okay, the register field to specify 60 processes, it is given. So this is for register, and register field to specify 60 process register, and the memory address. So this is last is memory is given. Okay, so we have to find the code field. So what is the size of this? This is 32. one sorry, one word. It is given as one word here. Okay, so 32 bit each. So this is the size of the the control word. Okay, so you have to find the operation code field. So to find operation code field, that means we can write it here. One word is equals to 32 bit, right? So let us start step by step. Okay, first thing what we have to solve is first given thing is what is given. Mode field is given as how much? 7. Okay, so how many bits we need to represent 7? That means 2 power 4, 2 power 2 is equals to 4, 2 power 3 is equals to 8. So we need at least 3 bits to represent, because 2 power 2 which is less than 7, which is less than 2 power 3. We need here 3 bits to represent mode field. Okay, so let us go to the B. Register address. Register address. For register address is given as how much? 60. Okay, to represent 60, how many bits we need? 2 power 5 is 32 and 2 power 6 is 64. So at least we need 2 power 5, which is less than 32. Sorry, which is less than 60, which is less than 2 power 6. So we need 6 bits to represent register address. And last thing is memory address. Memory address. So to represent memory address is given as 256 kilo. So 256 kilo is represented as 1 kilo is equals to 1024. Yes or no? So 256 kilo is represented as 1024, right? 1024. So 2 power 8 into 2 power 10 becomes 2 power 18. So we need 18 bits to represent memory address. Okay, so finally opcode. So what is opcode? How to find the opcode? So what is the size of the control word? Size of control word is equals to 32. So that means 32 minus what is the size of, so what is the size of mode field? 3. What is the register size of register address? 6 and 18. So 3 plus 6 plus 18 becomes how much? 32 minus 27 becomes 5. So let us arrange properly. So total size of the control, sorry, size of the control word is, so we will arrange accordingly. Okay, so mode field is 3. Yes or no? Opcode is 5 and register address is 6 and the memory address is 18. So when you add this all together, it becomes 32. This is a size. Okay, so we calculated opcode. It is 5. Okay, is that clear? So question 5. Write a program to evaluate the following arithmetic expression x equals to. So we have to write the program to evaluate the expression a cross b by c cross d. Okay. So here a cross b and c cross d is given. So you have to write the program for a following arithmetic expression using general register computer with a 3 address, 2 address, 1 address, and 0 address. Okay. So first we start writing this program for 3 address using 3 address. Okay. So 3 address itself, it is clearly saying that you can use 3 registers here. Okay. So that means x equals to a cross b by c cross d. Okay. So when you write a cross b by c cross d, so first operation what I am performing is multiplying. What I am multiplying a cross b. That means the content, that means r1 comma a comma b. Okay. What I am doing, multiplying a and b and storing the result in r1. Okay. So let me write here, r1 implies memory address at a cross b. Okay, that means I'm multiplying a and b and storing the result in r1. Okay, same way what I will do, I will multiply r2 c comma d. That means I can use, here I have used only one register here, second register. Okay, so r2 implies memory addresses at c and content on d. Both are multiplying and storing result in r2. So now what we will do, third expression is divide. Third step is divide x. Okay, we'll use the accumulator or register x, r1 and r2. Okay, because here the our given destination is x, so we are using a register x. So x implies r1 by r. So that means here we are using R1, R2, and X, three registers. So this is simple. So in the second part, we are going to use only two addresses. So here that means 1, 2, 3 is finished. So we will go to the two addressing. So when it is two addressing, when it is two addressing, X equals to A cross B over C cross D. This is the given thing. Okay. So now what I'm going to use is, here I'm going to use two address only. So let us use move r1 comma a. That means content of a is moved to r1. This means I can write r1 implies address at a. Okay. Move, not move, just what we will do is here, will a cross b. Okay, so directly we can multiply multiply what, r1. That means now r1 is a, yes or no, comma b. So that means we are multiplying a with b. So R1 equals R1 cross, so memory, okay. So this is first step is done. Okay, so we here only we used R1. Okay, same way move R2 comma C. So R2 implies memory address at C. Okay, now R2 contains C. Then we are going to do the multiplication operation. Multiply R2 comma D, which means R2 is updated with what is update R2 is updated with R2 cross at D. Okay, here we multiplied R1 with B and update the R1 and we updated R2. Now we use R1 and R2, two addresses we already used. So now we will divide. What we will divide? We'll divide R1 comma R2. That means R1, any register R1, I will update it with R1 by R2. So now R1 contains what? The result. R1 contains R1 by R2. What is R1? R1 is A cross B, R2 is B cross C cross D. Okay. So now R1 is updated with the R1 by R2. So now lastly we move the content to X from R1. So that means memory address is moved to from R1 to X. Okay, here we are using R1 and R2, two address. Okay, so third one is two addressing. So see, so what is the given expression? X equals, sorry, A cross B by C cross D. This is the given thing, okay? So here we have to use only one addressing, one address. So let us use load A. So load A means accumulator. Okay, we'll use only one accumulator here. Accumulator is loaded with A. Okay. Now after loading, directly we will multiply B. So that means now accumulator value is updated with mem A, memory address at A. Oh, sorry. So because already accumulator consists of A1. So accumulator cross, so this accumulator cross at B. Okay, so B is updated. Sorry, accumulator is updated with A cross B. Now only we are allowed to use one accumulator only. So I cannot use a second thing. So what I will do is I will transfer the content into the temporary register. So what is temporary register here? So let us store store T. T indicates temporary register. Okay, so we are storing a T with the accumulator. Now accumulator data is transferred to T. That means temporary register contains now A cross B. Okay. So later on we can use this temporary register value. Next, again same thing. Load. What I will load here with C. Okay. Accumulator value is loaded with the address at C. And again same thing, multiply with T. So accumulator value is updated with accumulator cross at D. Okay. So we have updated accumulator with C cross. Here we have performed C cross D. Here we have performed A cross B. Now A T contains A cross B and accumulator contains C cross D. So now what I will do? I will divide. What I will divide? What I will divide? Divide T. That means accumulator value is updated with memory address T by accumulator. Yes or no? So this is A cross B and this is C cross D. Now T temporary register. Sorry. Now accumulator consists of A cross B by C cross D. That means here this accumulator contains A cross B, and now this accumulator T is A cross B, and accumulator consists of C cross D. So now accumulator is updated with A cross B by C cross D. So we will update and store store in X. So memory of X is stored with the accumulator. So this is here I'm using only one accumulator, but so here I'm using temporary register. Okay, so temporary register you can use when it is two addressing. Okay, so now finally zero addressing. Zero addressing means zero. So given expression is X equals to A cross B by C cross D. So we will use stack operation that is called as a push and pop. So first we will push. What we will push first? Push A. Okay, that means when you are pushing A, the top of stack indicates A. T P implies top of stack. Okay. Push A means top of stack. Push B is top of stack implies at B. Okay. Then multiply. What you will multiply here? You will multiply that now top of stack is at A cross B. Okay. Just we have done this like this. Okay. A will come, top of stack is at A, top of stack is at B. That means now A cross B. The top of stack is at A cross B. Okay. So again push. What we will push? C. So top of stack is at C. Push D. Top of stack is at D. Okay. Again multiply So top of stack is at C cross D. Okay. Now divide. So top of stack is at A cross B by C cross D. Okay. And so top of stack consists of A cross B by C cross D. So that means so memory address at X implies top of stack. Okay. This is for zero addressing. So let us come to the final addressing modes. So addressing mode, the sorry, an instruction is stored at a location 300 with its addressing field at 301. The addressing field has a value 400. The process register R1 contains number 200. Evaluate the effective address. If the addressing mode of the instruction is direct, immediate, relative, register indirect, and index with R1 as a index register. Okay. So first you have to calculate the direct addressing. Here what you have to calculate an instruction stored at the location for effective address. You have to calculate the effective address. When you are calculating effective address, you have to deal with only address, not opcodes. Okay. So let us write the given things. Okay. What are the given things here? So given thing is, let me write it. Code. Okay. And mode. So 300. The instruction is stored at the location 300 with the address field located at 301. Okay, and so this is PC program counter. Program counter is, indicates the next instruction. What is at 301? The address has the value of 400. Okay, and the process register R1 contains process register R1 contains number 200. Okay, so first calculate the direct address. Direct address is nothing but direct, so direct address is z, suppose, which is address field. Okay, so what is address field here? The there is 300 with an address field located at 301. Okay, address field is a 301 which contains number 400. Okay, so z equals to 400. Okay, so immediate, what is immediate, what is address field, the look at this location, what is the address? So we can add address field of, okay, so it is 301. So next, that is relative. Relative address z equals to program counter or next instruction PC plus R1. The register R1 contains the number 200. Okay, so 302 plus 200. Oh, sorry. This is address field. Okay, this is address field. Address field. So address field is 400, which is equals to 702. Okay, and finally, no register indirect. Register indirect is z equals to given, that means R1. So finally, index. Index is nothing but z equals to XR. That means the register given register R1 plus address address field. So it is z equals to XR is 200 R1. Okay, and address field is 400. It is 600. So this is the addressing mode. Here you are calculating effective address. Okay, so hope you understand. Thank you for listening. If you have any queries, you can write me the email.